So I'd like to take a little bit of time here to explain to you more about the FAD Tools program and speak to you a little bit about what makes FAD Tools unique compared to some of the other programs that are out there to analyze and design foundations. FAD Tools is comprised of three separate programs. The first program is FAD, which stands for Moment Foundation Analysis and Design, and it's used to analyze and design drilled shafts and direct embedded poles that experience axial compression loads, lateral shear loads, as well as moment loadings for steel pole foundations. The second program is called HFAD and is used specifically to analyze and design drilled shafts and direct embedded poles for H-frame structures that experience axial loading, both compression and uplift, as well as lateral loads and moment loading. And the final program that comprises the FAD Tools suite is TFAD. TFAD is used specifically for the analysis and design of drilled shafts for lattice tower foundations. FAD Tools is a unique program, and what makes FAD Tools unique is that it was developed specifically with the transmission line industry in mind. Each of these programs was designed specifically for designing and analyzing foundations for transmission line structures. And there's a number of things that make this program unique, but one of the main things, one of the focal points of this program is the fact that each of the models for FAD, HFAD, and TFAD were developed specifically from actual full-scale load test data, full-scale load tests that were performed on drilled shaft foundations. The way in which those load tests were used is through a calibration process. The way in which calibration works is that you take actual results from full-scale load tests and you put that on a graph and you plot the actual capacities from the full-scale load tests versus the capacity that you predict using the model, whether it's FAD, HFAD, or TFAD. And you get a bunch of points on a graph and they're scattered. The next thing that you would do is draw a line through those points that are on that graph, and we refer to that as a least squared fit line to get a general idea of how well your model is predicting the actual results of the full-scale load test. And one of the ways in which you can assess that is the slope of the line. If that line were 45 degrees, it would in theory be predicting the actual full-scale load test results perfectly. The last thing that you want to do is somehow evaluate the scatter of the plots. And we call that a coefficient of variation. And what FAD tries to do is model the approach that's taken in ASCE manual number 74 and develop a strength factor that is going to keep all of your design capacities within the 5% lower exclusion limit. And that is represented by the red line on the bottom. So what FAD produces as an end result is a nominal capacity, which is in essence your ultimate capacity if you're used to allowable stress design. And it also produces a design capacity, which is calculated based on applying a strength factor, which is developed from the calibration process of all of these load tests, these full-scale load tests that were used to develop the models for each of these programs. There's three main things that make FAD Tools unique program to use for the design and analysis of foundations for transmission line structures. The first and main point is the fact that each of the models was developed using full-scale load test data. The second reason why FAD Tools is unique to the industry is the fact that there are actually three tools that were developed for the design and analysis of these foundations. There's a separate tool for single pole structures, there's a separate tool for H-frame structures, and a separate one for tower foundations. And the reason for that is because the loading that these foundations experience is very unique, and as a result, the way in which they're analyzed should also be unique. And the final reason which makes FAD Tools unique, which is not to be understated, is the relative ease of use of the program itself. And really this is accomplished through the use of libraries, where the user can enter in soil profiles, loading cases, performance criteria, and foundation information, and use that over and over again for successive design runs rather than having to enter it every time that the user wants to design an individual foundation. We're very excited for the future of this program. FAD Tools has a very rich and unique history, and we look forward to receiving your feedback about the program, whether that's through the use of our users group or contacting us directly to give us great ideas to use to help make this a better program moving forward. The FAD Tools program is exclusively managed and licensed by DiGioia Gray & Associates. We look forward to hearing from you.